Good morning, good afternoon, and a very warm welcome to the Bureau Veritas webinar, the LNG Value Chain, How Far Will It Grow? I'm Ulrik Frøger, Marine Commercial Director at Bureau Veritas, and I have the pleasure to moderate this webinar, assisted by colleagues from our head office here in Paris. I'm pleased to introduce the BV team of speakers today. José Esteve, our offshore gas and power market leader, Benoit Grouvel, our gas expertise team director, and Carlos Guerrero, our global market leader for gas carriers. We have prepared the following agenda for today's webinar. We will touch on FLNGs, FSRUs, and LNG carriers, as well as LNG bunkering vessels. All this naturally leads us to ask the question whether LNG as fuel can continuously be considered as one of the future solutions for main fuel to be used. We will end this webinar with a short Q&A session. You will be able to ask us questions. Please post your questions directly in the Q&A box on the top right-hand side of your screen. You have to click on the Q&A, otherwise it will go only in the chat. At the end of the session, we will try and take as many questions as we can, and if time does not allow all of the questions to be replied, I will come back to you later this week. We will also run a few polls with questions to share a sense of what you, the audience, are thinking. These will pop up during the presentations, and result can be seen by clicking on the poll box. That poll box is next to the Q&A on the top right of your screen. And of course, we are sharing today's presentation. You can either download it now in the handout section or get back to us later this week. We will also send you a link for the download of the recording of this presentation. Bureau Veritas Group is active on the oil and gas installations with services combined from two of our divisions, Marine and Offshore, and the industry business lines. The BV Group today employs 82,000 people worldwide with a revenue of nearly 6 billion euros in 2023. The numbers for 2024 to be announced on February 25. The key numbers for the marine classification is that we today have more than 12,000 vessels in our register, and hereby 265 LNG carriers and 47 FSRUs and FLNGs. We serve the fleet based on 150 flag recognitions. The organization of the marine activity is highly based on a decentralized operation with 6 operational centers and 19 approval offices. We have presently 267 gas qualified surveyors. Analysts are predicting that the global gas demand will increase 20% by 2040, and the reason why we today see increased investments into production of LNG. We will likely see a 50% increase by 2030 and perhaps even a 150% increase by 2035. Today we note 66 FSRUs and 25 LNG projects, and with an order book of 341 LNG carriers. And we can ask the question, will this be sufficient? Using LNG as fuel is also increasing as the number of vessels capable to use LNG will double in the years to come. For land transport and considering Asia only, the number of trucks using LNG as fuel will likewise be doubled soon. The prospects of liquefaction capacity will give us a 2.5 increase of production capacity in the coming years, with a significant part in the US. For the regasification, the LNG to power is changing the situation for the FSRUs, as they are now often included as source in an offshore power plant development. The regasification capacity worldwide is foreseen to increase by 50% in the coming years. And just a quick overview of the Bureau Veritas fleet. So we are classing 22 FSRUs, 1 FLNG, and 4 LNG FSUs. And according to our numbers, we estimate around a 36% market share expressed in the number of units. When looking at LNG carriers and bunkering vessels, and across both existing fleet and order book, We estimate around 18% of the vessels in numbers are classed by Bureau Veritas. And let's launch the first poll and hear your comments to that. So, would you want a dedicated webinar on one of the following topics mentioned in our introduction? FLNG, FSRUs, LNG carriers, LNG bunkering, LNG fuel, or gas-powered barges? Please indicate your reply and click on the submit to move to the next screen. And now I would like to introduce the next speaker, which is José Esteve, who will tell us about FLNG.
Thank you very much, Ulrich. Hello, everybody. I'm José Esteve. I'm the offshore gas and power market leader for Bureau Veritas here in Paris. As explained by Ulrich, there is a huge prospect in liquefaction capacity in the coming years. If all of these prospects become true, then we will be multiplying by 2.5 times the current LNG production capacity worldwide. And then FLNG projects are an interesting part of that new production capacity that will come online. As we can see, for all the projects that we are aware of, there is nearly in every continent an FLNG project, with the African and the North American regions having the largest number of projects regarding FLNGs. Currently producing, we have 8 FLNGs, and we can see a variety of versions or types. So we have 4 of the current producing FLNGs are new builds using membrane type cargo containment systems. 2 of them are conversions using MOS type units, and we have 2 interesting redeployments. The Altamira FLNG that is using jackups and an LNG FSU, and the Marine 12 FLNG in Congo that is using 2 floating units, what was initially a nearshore unit and an LNG FSU. And coming shortly in the next 12 to 16 months, we are expecting to see 3 new FLNGs and 2 newcomers in terms of cargo containment systems, as we are going to see the Nguya and the Kasuri FLNG built by Wison using SPV tanks. And then we will have a new membrane vessel, the 3rd FLNG for Petronas. So we are seeing an increased attention and prospects for FLNGs, and we expect this to continue growing in the coming years. And we do stop on the industry resourcefulness that we have seen with the Altamira, and in particular with also the Marine 12, where we've seen the first ever redeployment of 2 units with a split mooring component that has allowed in the fastest ever redeployment of oil and gas units that Congo becomes an LNG exporter, and has shown the industry resourcefulness that we see in other projects in North America to have projects deployed fast and economically in order to match the increased demand that we are seeing in the LNG. Now, switching to FSRUs, this is also a very interesting market, because we have 66 projects identified in all continents. We are seeing a doubling of the current fleet of FSRUs. These units are usually liquefied gas carriers with regasification capacity that retain the trading propulsion capacity, so they can switch between being a regasification unit into going back to trading ship. And once again, we see also Africa being one of the locations where we are going to see FSRUs, but India, South Asia, and of course Europe, where we saw 12 projects deployed in less than 12 months. Now, the interesting subject of FSRUs is more related also to the increased gas to power interest that has come up in the last months. And Looking at the different prospects of power plants, we see that natural gas is gaining attention and gaining traction both in the plant capacity, as you can see, compared to coal and nuclear, and to the number of projects that are currently being followed up all over the world. And within this gas to power, we see specifically the LNG to power, where we see FSRUs that are being considered in several countries in South Asia, in America, and in the Caribbean, where FSRUs will become the storage for then transferring directly the LNG, now gas, in gas form, for a dedicated gas power plant. And in this sense, I would like to mention two particular case studies classed by Bureau Veritas: the Jawa Satu FSRU in Indonesia, which was the first Asian gas to power project using an FSRU, having 300 million cubic feet per day of gasification capacity, and linked to a direct gas power project. And then we have this very interesting project of the Port of Itaguaí that is combining FSRU and power ships connected directly to the electrical grid, all of them deployed through the Carmola and Car Power Ship partnership that allows providing this LNG to power prospect to Brazil. And I give back the floor to my colleague, Carlos Guerrero, who will be speaking about LNG carriers.
Thank you, Jose. So my name is Carlos Guerrero. I'm Global Market Leader for Gas Carriers, and I will be the speaker for this section of this presentation. So let's go to talk about the transportation of LNG. First, in this slide, I wanted to show you what is, in our view, the forecast on short term till 2030 of LNG carriers above 40,000 cubic meters capacity. So we are excluding the small scale LNG carriers basically, and only ships that are really involved in trading between terminals on large scale are included in this forecast. We are using data coming from Clarksons and other companies, in fact, that are developing reports on LNG, and our own data regarding the number of ships in service. On short term, we expect that the trade will increase, but we need to be a bit conservative because there have been also some delays in the developments of liquefaction terminals. Our estimation is that this growth might be in the range of 4 to 5% per year. And in this graph, you can see the LNG trade growing until 2030 at this level. We may expect that maybe later in the 30s or later in 2040 might be, depending on other alternatives, a plateau for the LNG trade, but this remains to be seen. The situation regarding new building contract is extremely, well, I would say, booming in the last years, but we may see some deceleration in the contracts for this year due to the present situation on short term and due to the extremely high price of the assets and the number of on-order ships compared to the ships in service. We are also a bit more aggressive on the scrapping levels, removals of ships, but we're still conservative because we see that there will be a trend to remove more vessels than before due to the environmental regulations and also because of the commercial pressure. But we may expect, in our opinion, no more than 12 vessels removed for the coming years. So the fleet, all in all, in 2030 might be in the range of 1,045 vessels. And the designs are still evolving. Of course, we in the last 5-7 years, we have seen the standard LNG carrier design with the capacity of 174, in a few cases 180,000, with the 4 tanks, and the technologies are already well known in terms of propulsion. with the last news about one of the existing engines that is not anymore available since October last year. But we see that there are also some other opportunities to develop new designs with new technologies and innovation that is becoming very interesting to follow. For instance, already some designs are considering 200,000 cubic meters with 4 tanks, and this is one of the, I would say, most interesting evolutions. We have seen, of course, that the economy of scale in some particular projects, not for portfolio players, but for time charter contract that are long term, might be interested to also to increase the capacity of the ship even to 271 with the latest QC vessels, QC Max vessels to be built by Hudong. And as we mentioned, again, the technologies are still evolving in terms of containment systems, in terms of propulsion. We will address some ideas in the next slides of the presentation. There are also future options, and at least one of the options that are indicated in this slide, also in the bottom of this page, has been proposed recently, at least for one LNG carrier on order, that is the wind-assisted propulsion. But of course, there are other options that are being at least considered in conceptual designs, like onboard carbon capture with post or pre-combustion concepts, and even alternative fuels. In this case, of course, with the boil of gas as the main fuel to reduce emissions, but maybe in the future in a combination with other type of fuels, why not with hydrogen? One of the topics we have seen is the evolution of the cargo containment systems. In this slide that is provided by GTT, you will see basically that there has been, from boil-off rate perspective, an evolution originally from 0.15% per volume at laden condition to the current levels that are very low, even half of the previous levels, because this is given, of course, the flexibility and is more aligned with the speed and with the operational profile of the ships these days that are not sailing as an average anymore above 16 knots, even if they are designed still today for the speed of 19.5. So the latest technology, of course, developed by GTT is the next one that has not been implemented, and the other technologies, Mark III or NO96, have reached already levels of 0.07 or 0.085 for the Super Plus in NO96. I will introduce just a few case studies just to show you what are the standard trends at this moment. The first example is a series of 3 ships delivered by Samsung Heavy Industry for Maran Gas. This is the standard, I would say, and fully flexible LNG carrier design with 174,000 cubic meters cargo capacity with the latest technologies, with air lubrication system and PTO, also to reduce the fuel consumption, with 4 membrane cargo tanks, Mark III Flex, that is giving, again, full flexibility for this type of ships. And of course, the twin screw and 2-stroke dual fuel engines that have been installed in these 3 ships with the latest technology that is providing the better efficiency as well. But there is, as I mentioned, an evolution, and is not potential, is already in service. This series of ships, in which BP is also involved as a class society, is a series of 14 ships built by Hyundai Heavy Industry. Part of the fleet, approximately half, is in service. Is a vessel that has a design of 4 tanks, only 4 tanks for 200k cubic meters. That is, in fact, impacting positively the fuel savings and the OPEX for this type of units. Is fully compatible with the Panama Canal, and as well is very flexible in terms of terminal capabilities and operations. The global efficiency is also very low because they are equipped with the latest Mark III Flex Plus cargo containment system. So this, together with the volume of tank, actually lead to a very, very low boil-off rate in the range of 0.065. Of course, there have been challenges in this design, like the sloshing that has been addressed, and there is no significant issue. There is no issue, in fact, technically, for the cargo containment systems, and the ships are in operation already, as I mentioned before. And we see also that there is another future, there is another way to address this type of projects. There have been also some ideas, very innovative, talking about the possibility to reduce the number of tanks. We have seen that the QC Max, of course, needs five tanks because the capacity is significant, 271,000. But for a ship that has got 200K, in fact, the existing one are equipped with 4 tanks, but there might be an option even to reduce to 3 tanks, with some challenge, as we know, regarding the, again, sloshing, potentially, or damage stability that have to be assessed properly, and have been assessed already in approval in principle that we have developed by Bureau Veritas. For this design that has been proposed by GTT, we have been involved not only as a class to assess and to issue the approval in principle, but also we have helped GTT in some preliminary concept optimization hull forms of this ship, because it's optimized also for an operational speed that is reduced compared to a standard LNG carrier these days. So, of course, the advantages we have already mentioned: you increase the volume of the ship, you reduce, in fact, the OPEX because it's more efficient than a standard LNG carrier. Could be also cheaper than a standard 200K because you reduce part of the cargo handling system and 1 tank. And, of course, in operation, you will get a very, very low boil-off rate compared to a standard LNG carrier, even of 200K. So I will introduce a poll now, very interesting one, I hope. So what do you think the LNG carrier order book is going to look like up to 2030? Please select one of the options. Thank you. Okay, thank you very much for your answers. And then I will be also very glad to talk about the bunkering vessels, LNG bunkering vessels. That is, in fact, a very interesting segment globally and also for Bureau Veritas. In fact, we know very well this small scale segment because we have been involved as class society for many projects in the past of small scale energy carriers that are in fact very similar to this new segment of LNG bunkering ships. And already in 2009, we classed one of the first multi-purpose gas carriers, and I can tell you on top of that, this LNG carrier on the left-hand side of the slide is in operation these days as an LNG bunkering ship. It was converted recently to LNG bunkering and is a dedicated ship in Europe. We have been the first class society also to issue specific regulations for LNG bunkering vessels. The first was issued in 2015, following requests from many stakeholders involved in this market, including port authorities, charterers, and other important relevant companies, shipyards, and ship owners. We have issued the last version in 2024, including all other alternative fuels. So we have 3 optional notations for bunkering ships. And we have a long history records of first ever on-purpose design and built LNG bunkering ships since 2017. In fact, the first seagoing ship, the Green Route, in operation now in Dubai, was dedicated for bunkering in the north of Europe, originally delivered by Hanjin Heavy Industry in 2017. And we have many other examples, as I can of course, talk about them in these slides, with membrane containment system as well as Type C, and the latest units entering into operation, for instance, in Europe, in the western part of Europe, or in Singapore. So if we speak about the involvement in particular as of today for pure LNG bunkering vessels, I want to highlight this because there are some small scale LNG ships that are involved as well in bunkering operations from time to time and might be adapted for these activities. But if we talk only exclusively about the ships that have been designed and are in operation for LNG bunkering, we are by far the number one class society involved in this market. As of today, we also have projects on order that you can see on the right-hand side of the slide in China and in Korea, in different shipyards for different clients, and also, again, to highlight that some of them are with Type C tanks, and one in particular, the last one for Ibaizábal in Hudong, Songhua is going to be equipped with GTT Mark III Flex technology. So we are optimistic on the market developments. In fact, if you see the order book of ships these days, is really a booming market for LNG bunkering. We have counted in our statistics, as we mentioned, around 32 pure LNG bunkering seagoing units deployed. To that unit, we have to add the inland navigation LNG bunkering barges or vessels that are also in operation, and some of them classed by Bureau Veritas. We have one case study to talk about this. And in addition, around 20 more, as I mentioned, small scale LNG carriers and these inland non-propelled units. There is growing demand. Europe has been pioneering in the ship-to-ship bunkering operations, but of course, United States, China, Japan, Korea, and Singapore in particular have followed. And now we are proud to say that the only ship in operation in the Middle East is also classed by Bureau Veritas, as I mentioned, the Green Approach. LNG is, as of today, an affordable alternative for fuel, for clean fuel. Price is still convenient, but of course we always have a kind of peak in the winter time, so now it's a bit less convenient than in December, but it's still affordable, especially when you have to cope with the new environmental regulations. Relevant bunkering hubs are already developed. There are still some places that need to develop these facilities, but everything is in good track and will be on time, hopefully. And the chicken and egg dilemma is completely over because all is in place to develop this business in terms of technologies, regulations, and availability of LNG worldwide. So we don't see any issue to develop the business further. And now I will pass the floor to Benoit, who's going to talk about these case studies. Thank you very much.
Thank you very much, Carlos. So now we will go through some few examples to show the diversity of the different type of LNG bunkering vessel. And our first example is this series of the largest one for bunkering vessel with membrane tanks. So 3 vessels built in the Chinese shipyard Hudong, and their particularity is, of course, these 2 huge membrane GTT Mark III Flex tanks, huge for a bunkering vessel. And one particularity is the extensive sloshing assessment, because as a bunkering vessel, the filling level will be different, and we need to be sure that the sloshing has been taken care of during the design. Some particularity that we'll find on some bunkering vessel: the propulsion, dual fuel diesel electric, and azimuth thrusters for the good maneuverability without going into this dynamic positioning capacity. And then also we'll find the manifold at different elevation to be compatible with different type of vessel. If we go for the next example, so this one a bit specific. This vessel made specifically for the port of Barcelona in Spain and to be compatible with passenger vessel. So the particularity in terms of tank, it's different, bilob Type C tanks. Then we'll have again the subcooling system and the midship and aft manifold. And in terms of propulsion, we'll see this gas fuel, diesel electric backup with a diesel engine, and then an azimuth thruster for the propulsion. So the particularity, as you can see on this vessel, very low air draft and accommodation forward. This is due to the compatibility with the vessel and the terminal. And then we'll go for the last example of this bunkering vessel. Very recently delivered. So inland navigation, 8,000 cubes bunkering vessel. So inland navigation means application of the ADN rules, which impose to have tanks not exceeding 1,000 cubic meters. So we have 8 Type C cylindrical tank. Subcooling system, midship manifold. In terms of propulsion, a bit similar, but with different makers. Gas fuel diesel engine, backup with diesel engine. And again, very low air draft and an area of operation, which is very specific, being an inland vessel. So that's for the bunkering vessel. Now maybe we'll go for the pole. So that's an introduction for the LNG as fuel. So I'll give you a few seconds to reply to this point. Okay, thank you very much. And now we'll go for the LNG as fuel. So LNG as fuel, and that's interesting for this poll. So we'll show you a few BV statistics, and the first one being on the 2024 order book. So it's the order book only for the year 24. So you can see two graphs, one being for the alternative fuel class notation, and the other one is including the prepared notation. So prepared notation means that the design has been reviewed and some of the equipments may have been installed, some space may have been reserved, but the installation is not complete. So we see that in the 2024 order book, in the alternative fuel distribution, the LNG is really the biggest share, up to 60%. Even looking at the prepared notation, 54%. 2023, we had a lot of methanol, but methanol in the 24 went slower a bit compared to the LNG. And then we see some few different alternative fuels. So LPG fuel, due to the huge order in 2024 of LPG carriers, naturally they went for LPG as fuel also, and some few niche market still on the hydrogen and the ammonia. And even if we see that ammonia is getting more and more attraction in the prepared market. Then if we go in the ship type, so again, these two graphs, one for the full notation, the other one including the prepared notation. Ship type, of course, we'll see gas tanker, but then we see that the biggest share will come on container vessel, and the second largest will come on tanker. We have some others, particularity, the bulk carrier. We see that prepared notation is getting a lot of attraction on the bulk carrier. So showing that ship owners are getting ready, but not yet implementing completely LNG as fuel. So in terms of BV involvement, more than 300 vessels classed with BV, so that's including the vessel delivered or in the construction phase. And again, we see in terms of share, we'll have, of course, the gas tanker. So container, as shown in the picture on the top left, chemical tankers, passenger vessels that were not represented in the 2024 orders, and then some special services such as offshore, tugs, supply vessel, or small cargo vessel. So why do we see so much attraction on this LNG? A first reply going into the regulation, EEDI and CII. So we all know that EEDI has been in application for some few years, and the CII more recently. So if we look at the formula of EEDI, you can see so that the main factor is the power of the main engine multiplied by a conversion factor, and then the specific fuel consumption. So if we take an example of a WinGD X92, which is quite a popular engine, and comparing the diesel version of this engine and the dual fuel version in gas mode. So the diesel version will have 150 grams per kilowatt hour, to be used with HFO conversion factor 3.114. If we go for the similar engine, but in dual fuel version, in gas consumption, we'll see that the biggest change will be the conversion factor of LNG, which is 2.75. So straight away, in the EDI value, we'll have more than 15% reduction when using the LNG or the dual fuel version of the engine. And the similar impact is expected on the CII calculation because you can see on the formula, the principle of the calculation is the same. So to be noted that on EDI and CII, we don't have the impact of the methane emission, the methane slip, only on the fuel EU, which is applied only for the vessel trading in EU. Then a second impact, if we follow the EDI and CII, would be what about the economics? So on the capex part, first new building, storage, LNG volumetric density compared to HFO being lower, you need more space. Then, of course, the main engine is more complex, and then, of course, you need to add some gas equipment for the treatment, including the bunkering, pumps, compressors, gas valve units, etc. Then, if we go into the OPEX part, ship in service, so additional items for maintenance due to the gas equipment, but keeping in mind that it's a cleaner fuel, and this may save a bit on the maintenance. You don't need to clean the purifiers, right? But we have also this innovative design, and then with new technology, you may have some breakdown or early breakdown and replacement of equipment. I would say that this phase is going down. The fuel cost is, of course, very important. So the graph on the top right, you see in dark blue the LNG price, and in light green the HSFO price. And we can see that the trend over the last year is that this price gap is going down, is reducing. So of course, this is an advantage for LNG. The bottom graph will show the price of HFO LNG compared to different alternative fuel, and we see that there is still a huge gap between HFO LNG and the other one. And we see also that sometimes HFO is higher than LNG, sometimes LNG is higher than HFO. But the arbitrage between these two fuels is not so easy because on an LNG tank, you will have to take care of the boil-off management. So when your tank is full, you cannot just close it and switch to HFO because you have to take care of the boil. Then, of course, we need to talk about the methane slip and the GHG of methane. And we all know that GHG of methane is much higher than CO2. So any leak of methane into the atmosphere has a very strong impact. So in terms of engine, this is applied particularly for the low pressure Otto cycle engine compared to the high pressure diesel cycle. But how to take care of that? Engine makers, they have worked on that for many years and they have improved a lot. How? Improving the combustion, exhaust gas recirculation that we see, and then some of the engine makers, they are claiming that up to 90% reduction in the last 30 years. Big improvement. In terms of abatement technology, there are also some possibilities treating the methane which is in the exhaust. Different possibility, the catalysts or the plasma, which are under development but showing very good results already with prototype installed. And then, of course, the usage of the shaft generator, replacing the running of the 4-stroke diesel engine by using power generation from the 2-stroke main engine is automatically reducing the methane slip emission. Also, don't forget that there have been some other emissions, the fugitive emissions, glands, compressor, valves, which have to be taken care by measurement and fixing these leaks. And then the control venting of the engine, typically the changeover and the start and stop. So it is showed that normally these values, these emissions are much lower than the methane slip, but they have to be taken care of. Now I will show you some few examples of typical vessel LNG as fuel. So the very typical one, container vessel, only one LNG tank, one huge membrane tank generally located below the accommodation. One 2-stroke main engine, generators with dual fuel capability, and because this tank is below the accommodation space, enclosed tank connection space, and a separated fuel preparation room, and double wall piping for the correct segregation between all these spaces and the main engine. Of course, we need a bunkering station on the main deck. Another example, very typical, a bit more simple, I would say, chemical tankers. So here we see in a bunkering operation, so it's not two chemical tankers, but the shape would look quite similar. And then we can see the differences. So vacuum insulated tank on deck with an integrated tank connection space with all equipment inside. Pumps, vaporizers, heaters, valves, all the control system. And then a single line going through the main deck and then entering in the engine room. So only a very limited routing of fuel piping with double wall inside the engine room. Generally, we'll find on this vessel generators without dual fuel capability, so quite simple design, and the venting on the deck, which is easy to manage on a chemical tank. Then the last one, a bit more complex, on passenger vessel. So the particularity on passenger vessel is you have to take care of the segregation between the hazardous area, non-hazardous, and the passenger spaces. So of course, most of the area on this vessel are passenger spaces. So you need a huge segregation philosophy. So we can see that these two Type C bilob tanks, they are embedded into the vessel, enclosed tank connection space that we can see. And then we'll have dual fuel boiler and a gas combustion unit as a redundancy to be able to manage the boil off. And then enclosed tank connection space, separated fuel preparation space. And fuel piping, everything in enclosed spaces or trunk with dedicated ventilation to be sure that we have a proper segregation. And then, of course, we need an enclosed bunkering station to be protected from the passenger spaces. Thank you very much. That's the last. And then I think we'll go through Q&A. Sorry, there is a poll.
All right, so we will move to questions, and we got all the speakers back on the stage. So let's see some of the questions that we have received. So we had a question from Franco asking about the perspective for use of bio-LNG as fuel.
Yeah, okay.
Benoit, maybe you would take that one.
Thank you, Carl. So yeah, thank you. Very, very interesting question. And definitely we see, so here I showed only values compared to normal LNG, but the bio LNG would be even more going through a transition into a net zero fuel. And we see this is really increasing. Advantage of the bio LNG being that chemically it's the same as the LNG. Compared to biofuel and fuel, it's a bit different. Bio LNG is the same chemical reaction as LNG, so very compatible to gas components, fuel pump compressors, and engines.
Okay, thank you, Benoit. So there was also a question that comes for the development of design of the LNG carriers, and it is, does there still exist a liquid level restriction to the latest membrane type tanks? And I know, Carlos, if you could
Yes.
give us a reply on that one.
Indeed, I will be pleased to reply. So, well, for a trading LNG carrier, normally the restrictions applied by GTT are still used. So basically the 10% lower filling level or the 70% for the upper filling level. Because basically there might be problems of sloshing, especially in the range of maybe 40 or 30 to 50%. Of the filling limit in the tanks. But this does not apply to the floating LNG in general that are reinforced for the purpose of coping with all filling limits. Normally for LNG carriers, we don't need this type of considerations. For standard LNG carriers, I would say. In some cases, for LNG bunkering vessels, has been the case that specific studies, in case the tank is not really at 10% or below, or 70 or more, is considered in the design.
Okay, and go back here and see. We have a question around the LNG bunkering capacities, whether it will improve worldwide in the coming years, because there's still a lot of blind spots around the globe.
Yes, it's a good one as well. Maybe I can answer this. Well, in fact, it will depend on the commercial aspect, not only the technical side of the business. We know that technically, regulatory framework and technology is ready, and there is no big issue, and the port authorities are more familiar with the LNG bunkering activities these days. But in fact, not in all regions still today they have access to LNG. I would say that this is one handicap, or it might be one handicap in some regions globally, but the main hubs that are bunkering ships will have access most probably in the coming years. Of course, assuming that it will be demand, and assuming that, of course, the price will be convenient, that this is our forecast, that this will be the scenario.
Okay. And we can go back and see here. There's a question about the LNG slip of the vessels 30 years ago compared to how it is today. And I think it would be fair to say that the engine manufacturers are working hard to find ways to reduce the methane slip. It is definitely a focus from all the partners working in this business with LNG as fuel. And there has been significant improvement, not only with the burning of the gas itself, but also the way that we measure the methane slip. I don't know if any of you would like to add on these comments or.
Yeah, methane slip, we see that in the LNG community, LNG as fuel, it's a concern for everybody. There have been a lot of initiative on that. Of course, measurement campaigns. We have the MAMI initiative, which is known to the industry, and it's worth mentioning that. We see that engine makers, they are making a lot of progress and huge progress. So I don't comment the 90% reduction. It's from an engine maker. So of course it depends on the loads. We see that. I mean, the focus really is on the two-stroke low pressure auto cycle, and now they are really going lower than the 1% value, which is then quite a huge improvement on a quite huge load. So that's a huge improvement. And then with the improvement of efficiency, the reduction of methane slip. I mean, the gap between GHG emission of diesel engine and the methane engine or gas fuel engine is really increasing. So we see a lot of progress on this one. I'm not saying that the progress are complete. It's still a challenge ahead, but we see a lot of improvement on that, and it will continue to improve. I saw, and we see that today in CII and EEDI, we don't have this taken into account. In the EU, we have it taken into account. Maybe in the future, this gap will close, and everybody will take that into account. Yeah.
And I will continue with a very it's a very good question, which came in about the VUCA effects in the LNG value chain. It's a very complicated question to answer shortly. I think Jose, you tried to write up a few sentences.
Say that again. Excuse me, say that again.
I come back to the question about the VUCA effects in the LNG
Yes.
value chain, and I said it's a very rich question. It requires a certain time to reply, but I think you can give a very short overview.
In fact, from regarding the volatility, we are seeing, as you probably are all aware of, the volatility of gas prices and the volatility of the charter rates that we are seeing currently in the spot LNG carrier market. But despite the volatility, we are still seeing clear support, financial support, and the FIDs, final investment decisions, going forward for both LNG production terminals and regasification terminals, as well as for gas power plants. Regarding uncertainty, what we see is that LNG is gaining traction and gaining interest and becoming a clear transition fuel for the next 15 to 20 years. So that removes the uncertainty of the LNG compared to other alternative fuels within the decarbonization climate market. And then on the complexity, the LNG value chain is a complex value chain with plenty of factors, but it has proven itself in the last 60 years, 70 years with a very robust track record. So there shouldn't be any risk there. And then the final one is on the availability. There will be still availability on the, as we see, on the expected production capacity coming up. So we are not too worried about the prospect and the future for LNG.
Thank you, Jose. We had also a question about the equipment on board the recent LNG carriers with relation to the liquefaction plant, as the boil-off gas is being reduced significantly. And Carlos, you have added some comments, or would give you the word to.
About the
Yes.
boil-off
Yes.
rate for.
Yeah, it has completely. It has been reduced significantly over the last couple of years, but that we still have the full flexibility for the vessels.
Exactly. I have in fact answered the question. Is I mean, it's very important to highlight that the charters in particular want to have, in any case, this flexibility to be able to burn boil-off gas or other fuels. Is of course important to highlight that due to the environmental regulations, it will be normally better to burn gas instead of oil fuel. But in any case, having a reliquefaction or subcooling system that is normally not full capacity, but part of partial capacity, is a feature that most of the LNG carriers have already these days.
We also have a question around the trend of the building new projects. So the question is the trend of building tankers capable to transport LNG, liquefied CO2 and ammonia likely to further develop?
Well,
yeah, so we see that. So the question on the LNG market is a valid one. So we have the poll, and we can see that the ideas are very widely spread. So today we have projection on LNG new liquefaction plant, which gives an idea on the number of LNG. And then, of course, we have the LNG order book. Will it continue? So that's the question on LNG being a transition fuel or being more than a transition fuel. How long will it be? Then the question on ammonia. So compatibility between LNG and ammonia, it's a bit difficult. We are on different type of vessel, different containment system. I mean, even if we have containment system compatible, but generally these are two different type of vessel. So yeah, definitely the ammonia LPG market The ships were in a boom last year. Will it continue? Looks like. LNG market, will it continue? How long will it continue? That's really an open question.
Jose, there is a question around the conversion of an FSU with a reliquefaction unit to be eventually retrofitted to provide alongside for an FSU to ship bunkering.
Well, it makes technical sense, and we have seen and we have had questions regarding this, and we have seen reliquefaction or subcooling units being installed in vessels. So the question is the economics of deploying these liquefaction unit, and how long do they expect the LNG to be stored before it is delivered as a fuel on the bunkering. But technically, it does make sense, particularly for older vessels that we are seeing older LNG carriers now being considered for LNG FSU or FSRUs with higher coilover rates. So then it can make sense. It is just a question of economically feasibility.
Okay. We can also take a market question in the sense that when we look into various broker reports, we can see that the rates for LNG carriers are quite low right now. And the question is that meaning that there's a loss of interest in the LNG construction?
That's a very interesting question.
I think, if I may, on this one, we see the effect on short term of some ships that have been delivered, especially in the last year, 24, that are not engaged yet in their relevant terminals, meaning that these terminals have been delayed. I can name a couple of these terminals like LNG, Canada LNG, or the Golden Bus in the US, and of course we have had this Biden administration pause also impacting, but not the terminals that were under construction. But basically there have been a mismatch between the LNG carriers delivered in the last year and the LNG terminal supply, supply terminal. So this causing this effect that is going to continue possibly for this year, 25, and potentially first quarter of next year. But on mid to long term, we are more optimistic, and of course there will be need for gas. So we are optimistic.
And I would follow up with a question to Jose. In addition to the FLNGs that you have mentioned in your slides, are there any other FLNG projects that you consider may arrive shortly or in a midterm?
So yes, I only mentioned the ones that are operating or that are in the last phases of construction. But yes, we've seen several announcements made for Argentina, for Nigeria, for the second FLNG for Mozambique, the two projects coming up with the floating production or storage in Canada. So yes, there are quite a number of projects that are going to happen for sure related to FLNG, with a combination of different solutions, conversion of MOX tankers, or having production on shore and the liquefied storage in a floating unit, or in Gabon, having the production on a pontoon and the LNG FSU separately. So a large number of options, and we see that the industry is very resourceful, and we see the demand pushing this need to bring projects online as fast as possible.
Thank you. I can see that time is gone for today, but I would like, on behalf of the entire Bureau Veritas group, thank you for connecting to our webinar and the time that you have invested. Please reach out to us here in Paris or to any of our local offices in case of question and further discussions. We will come back to you with the presentation as well as the answer to the questions that we did not have time to raise. Be safe and have a great day.
Thank you.
Thank you.
Bye-bye.